Hello, Miss Dawson here. Today I'm going to talk to you about area model multiplication and connecting it with expanded algorithm. So those are two different methods, but they're kind of connected, and I'll show you how. So first off, let's come up with a math problem like 21 times 17, okay? 21 times 17. Now, in area model, we are going to make our box method. I call it the window method because we make a visual and it looks like a window. It's basically just making 4 quadrants, okay? And in this method, you need to break apart your numbers by their ones place and their tens place. So 21 breaks apart into 20 and 1. 17 breaks apart into 10 and 7. Now, for this method, you solve for each quadrant and you get 4 partial products. So I'm going to solve for each of them. 10 times 20. 1 times 2 is 2, and then I have 2 extra zeros, so that would be 200. 7 times 20. 7 times 2 is 14, and then I have 1 extra 0, so it's 140. 10 times 1 is 10. And 7 times 1 is 7. So those 4 numbers are my partial products. So I would add them up to get my answer. 200 plus 140 plus 10 plus 7. And I would get 357 is my answer. This is your area model method, okay? We've had some practice with this. You can keep doing it this way, but I'm going to show you an even shorter way. It's less writing, and it leads us into just standard multiplication. So I'm going to do the same problem, 21 times 17, only we're going to set it up and down, okay? It doesn't matter what number's on top because it's 2-digit by 2-digit, so doesn't have to be the bigger number. I get in the habit of putting the bigger number on top, but you don't have to. 21 times 17. Now your first thing that you're going to do is you are going to solve the ones places. 7 times 1. 7 times 1 is 7. Okay? If you look over here, that's what we did in this quadrant. Okay? 7 times 20. 7 times 20. You should be able to do that mental math. 7 times 20. 7 times 2 is 14, and you have 1 extra 0, so it's 140. That was this one right here. We're essentially doing the same thing, only we're doing it mentally. 10 times 1. Now, why is this a 10? Because it's a 1 and it's in the 10 spot. So 10 times 1 is 10. And the last one is 10 times 20. 2 plus 2 extra zeros, 200. Do you see these numbers that we have? These numbers are the same as these numbers. It's doing area model, only you're not writing it all out, you're doing it mentally. And then when you get into standard algorithm, you're going to do even less writing because you're doing even more things mentally. So that's why it's so good to get really quick on your math facts, because once you get older, you'll start to do a lot more of it in your head. So let's add these up. I got the same answer. You should get the same answer because it's the same math problem. Okay, so let's try one more. We'll do an area model first, and then we will do it in expanded form. So let's do 25 times 18. 25 times 18. I'm going to do my box. 25 breaks apart into 20 and 5. 18 breaks apart into 10 and 8. And you need to solve for each quadrant. 10 times 20 is 200. 8 times 20, 8 times 2 is 16, and I have 1 extra 0. 10 times 5 is 50, and 8 times 5 is 40. These are my partial products. I need to add them all up. 200 plus 160 plus 40 plus 50. 0, that's 10 plus 5, carry your 1, 1, 2, 3, 4. 450 is what I got, 450. Now let's see if I can do it the same way in expanded algorithm. Remember, you set it up and down. I tend to put the bigger number on top. 8 times 5. 8 times 5 is 40. 8 times 20. 8 times 20 is 160. 10 times 5. 10 times 5 is 50. And the last one is 10 times 20, which is 200. My numbers should match. You add them up. 0, it's 10, 15. Put your 5, carry your 1. 1, 2, 3, 4. 450. So that's how you connect area model to expanded algorithm. Same partial products, only instead of drawing it out, you're doing it in your old noggin.